All right, this is Unit 5, Day 1, and this unit is called Square Root Functions and Radicals. Now, radicals is just another name for square root. So, it says graph y equals f of x without the use of a calculator. All right, guys, so if you have to take a square root of the number, up until this point, we know that the only nice square roots are going to be those of a perfect square. So 0 is pretty easy because when you plug in this x into this function, the square root of 0 is 0. The square root of 1 is 1. The next x that makes sense would be 4. 4 is your next perfect square, and the square root of 4 is 2. Then you're going to plug in 9 for x because the square root of 9 is 3. And there's no room on the graph, but then you would go 16 and 4. And 25 and 5, and so forth, okay? So if we plot these first 4 points, we're going to end up at 0, 0, 1, 1, 4, 2, and 9, 3. Okay? So here is the square root graph, okay? That's the parent graph. So all of these points right here are on that graph. It says label this equation. We did. Using your calculator to generate a table of values, graph the g function on the same grid of its label's equation. Start your tables at -10 to see certain x values not in the domain of this function. Okay? So if you were to put this in your graphing calculator, if you were to start your table way back in the negatives, you're not going to see them. It's going to say error. Okay, why? Because the square root of a negative number doesn't exist yet for us. Okay, so now if I were to plot that actual graph, I am going to, it would be here. Okay, so here is the G graph. And if you notice the location, okay, if you notice the location from the original origin, it moved over 1, 2, 3 to the left and down 2. Look at that right here. Okay? Think of that as your horizontal shift, and it's always opposite. That was left 3, then down 2. So that was my C and my D in CBAD. So it was a horizontal shift left 2 and then a vertical shift, horizontal shift left 3 and then a vertical shift down 2. Okay, so that actually is going to be part D here. I kind of jumped ahead. So there's my C, there's my D. So my C was left 3, and my D, there's no B and no A, was, that's hard to see there, let me clarify that for you, and then down 2. Okay, order is appropriate, so you always think of CBAD. Okay, now looking back at that graph here, the black function drawn in my black pen here is the original function, the square root of x, the domain. Okay, if you need help with this, the domain goes from left, so here's my left line, to right. And that black graph goes from, for all x such that, because it did say in set builder notation, it starts at 0 and goes anything bigger. So x is greater than or equal to 0. Okay. The range of that function is going to be the lowest point to its highest point. And that's going to be for all y, because we're talking about range, y is greater than or equal to 0. Because it's starting as low as 0 and the black graph continues up to infinity because of that arrow. Now my blue graph, its domain, that's as far as left as it goes, and that's as far right. Okay, so now its domain is for all x such that x will be greater than or equal to -3, because that's where that is right there. There's -3, and it's going all the way to infinity. So it's anything greater than or equal to -3. All right, its range, its lowest point is at -2. Its highest point is at infinity because of the arrow. So for all y's such that y is greater than or equal to -2. Okay, so you guys can see that little, how that pertains. That was left 3, so it's -3, and then that's -2. So that has to deal with domain and range. Okay, moving on here to example 2. Which of the following equations would represent the graph shown below? Try to answer the question without the use of your calculator. What transformations are you seeing on the parent function? All right, so now remember, your parent function did something like this. Okay, there was my parent function. So it definitely was a reflection. It definitely flipped over the x-axis. Okay, so if you can imagine it flipping over the x-axis, it would look like that. So there's my reflection over my x, but now look, it shifted 1, 2, 3, 4 to the left. And because it shifted left 4, you know it's the opposite sign, it has to be +4. Okay, so it's going to be choice 1. Okay, there's my A, there's my reflection. That negative sign indicates it was a reflection over the x-axis, and then the +4 meant left 4. Now, according to CBAD, the shift left 4 happened first, and then the reflection. So it actually moved over here first, and it would look like this. So I probably should not do that yet. So here is the whole graph shifted over first, and then it flipped over. Okay? All right, example 3. Which of the following values of x does not lie in the domain? So now we learned for any, this was in like unit 1 or unit 2, I think it was unit 1, we had a restricted domain. If it was a square root, you take whatever's underneath the square root and you set it greater than or equal to 0. Now when I solve for x, I would add 5 to both sides, and I get that x has to be greater than or equal to 5. So all numbers that satisfy this are going to be 5 and bigger. So the only one that doesn't satisfy it is 2. It says explain why it does not lie there. Well, something easy to think about it is if you were to substitute in a 2, you're going to get the square root of a -3, and that doesn't exist yet for us. Or think about that graph. That graph is 5, so if you shifted 5 to the right, there's your square root graph. The domain goes from 5 and bigger, so 2 does not fall in it. Example 4, determine the domain, and then this was just talking about set the radicand, the number inside the square root symbol, to greater than or equal to 0. So that's what I was just talking about. So you're going to take what's underneath it. So I'm going to take the x plus 2, and I set it greater than or equal to 0. So if I minus 2 from both sides, I'm going to get x is greater than or equal to -2. So set builder notation would be for all x such that x is greater than or equal to -2. There's my set builder. Now for interval notation, because it wants it in interval as well, it's going to go from -2, and that's included, and then it goes to positive infinity, which is not included. Okay, this one, 3x minus 2 greater than or equal to 0. I add 2 to both sides, and then I divide by 3. So I get x is greater than or equal to 2/3. So set builder notation for all x such that x is greater than or equal to 2/3. Or it's going to be 2/3 is included to positive infinity not included. Okay. C is special. You're going to see why in a minute. So 8 minus 2x is greater than or equal to 0. I subtract 8 from both sides, and I get -8. Now, I'm dividing both sides by a -2. Okay? Anytime you divide by a negative, you have to remember to flip the sign. So it's going to become x, for all x, such that x, flip the sign, so now it's less than or equal to +4. Okay, again, negative 8 divided by negative 2 is a positive 4, but because I'm dividing by a negative, that sign there had to flip, and now it becomes less than. Okay? You can always check these out in your graphing calculator, and it would show you that picture that would support your answer. All right, so now if it's any number less than or equal to 4, that means you're going to be at negative infinity first, and it goes up to positive 4 included. Example 5. Use your calculator to sketch the function on the axes given. All right. So this is negative 6, and this is positive 3. And again, guys, the only thing I did, you put this whole thing in your graphing calculator, and then hit Control-T and get your table. So one of the nice points I see is negative 7, 3. Okay, and then I also see that negative 6, 0 is a nice one. And then if I continue on to the positives, I see 2, 0. But then I also see 3, 3. And then it just kind of looks something like this. So it's kind of a little different graph there. Set up and solve a quadratic inequality that will yield the domain. Remember, guys, whatever's underneath the radical gets set greater than or equal to 0 anytime it's a square root. So now when I solve this, treat this like this is a 0. So now graphically, this greater than, if you remember back to, I think it was in the quadratic unit, so unit 2, because it's greater, we already know that it's going to be a disjunction, which is disconnected. So it's going to have an OR statement. Okay, it's going to have an OR statement. Now, to figure out what the numbers are, you're going to factor this like it's 0. So what multiplies to a negative 12, but then would add up to a positive 4, you split this down the middle, you're going to get negative 6 and positive 2. Okay, so on the number line, you would have, this would be your negative 6, this would be your positive 2, and they're filled in, and there's your what it looks like graphically. Why does this number make sense? Look up here, guys. It's anything from negative 6 and less. So what does that mean? That means for all x such that x is less than or equal to negative 6. So it's negative 6 and lower, or, because it's a disjunction, x is greater than or equal to 2. Right here. So anything here and higher. Okay, so this should make sense. You should be going, oh yeah, it makes sense. That's why this graph looked like that. Okay, and those are just the kind of the steps if you forgot.